there's about the max flow that we can have stability at. We'll go ahead and back the air off, and we'll go ahead and display what it looks like when it is in a more rich condition. Slowly you notice the yellowish starts to come back, or the orange. That is in a rich configuration. I'm not exactly sure how the air is flowing. The inside dimension of this glass may not quite be large enough, so some of this turbulence may be due to incorrect proportions, and so that's something we'll need to investigate. Although I am pretty pleased with the way this is functioning so far. We'll continue to go into more of a rich combustion condition. See more of a kind of a greenish color towards the center. And that marks a very rich condition. In fact, the top of that probably is very flammable. Certainly some fuel coming out of the top there, probably in the form of a more hydrogen-rich mixture. Now we'll go right back into a lean mode of operation. By the way, this particular in this mixture of air and fuel, this is going to give us basically the highest temperature that we will see. So the outside of that container, if this was stainless steel, you would see a red glow. But since this is glass, for some reason it doesn't glow as brightly. But we did notice after the last shutdown, when we turned the fuel off for probably 10-15 seconds, the glass was actually glowing red hot. Flame seems to be stable when it's in a more rich setting. Perhaps that has to do simply with the air-fuel mixture, and also probably the gas velocity inside the combustor. Seems like the more flow, the more turbulent. Also, I'd like to point out when the reactor itself, the combustor, is at elevated temperatures like it is now, it has a very wide range at which it can be operated. You could run it very rich or very lean and it's okay. It seems to not mind that too much, and it doesn't seem to mind to just kind of stabilize on its own. Going into a very rich condition right now. Probably will notice in a second. We may notice some flames coming from the top of the unit. Also, the vessel is cooling down slowly right now. We're not producing as much heat, so it's possible that it may reduce its stability simply because of that as well. So our flame on the inside might completely go out. Here's the flame on the top, like I was mentioning, and That's because we're in such a rich configuration. Some of that fuel is escaping and not being fully reacted. As you can see there, that flame on the top is very orangish yellow, indicating carbon that's incandescing. When carbon gets extremely excited, when its energy state is raised, it will be just like a light bulb. It'll glow. Now, instead of that chemical energy going into heat, which is what we want, because heat we can use to do work, we don't really want it to go to light. And so anytime you see a carbon go into a more yellow, orange configuration, that's generally not a good thing. Generally, we don't have units like this just simply to produce light. Of course, we want them to do something a little more useful, like burning in our engines, or producing electricity or some type of mechanical energy. Now we'll see if we'll get this thing to cooperate with us, and we'll go back into a high flow lead configuration, and the unit's actually cooled down, and that's why we're having some issues getting it to go into that full flow for us. Like I mentioned earlier, anytime the device cools down, it seems to not tolerate high flows, and it seems to not tolerate extremes, whether too rich or too lean. But once you have it hot, it doesn't mind to go rich, lean, and it doesn't mind low or high flow rates. So it's it likes to have a certain temperature and kind of be maintained there. Slowly, with each puff, we're gaining temperature on the inside, and so eventually here we'll be able to get a nice stable combustion on the inside, with a little bit of luck. I'm particularly happy that this glass is actually holding up. I had anticipated that this would not allow us to run it like we have, and so that means to me I can put electrodes in it, put some high voltage in it, and see if we can get some plasma chemical reactions going. Well, it doesn't look like it's going to let us go back into the full flow, so we'll go ahead and call it good on this particular video.